All right. Well, we're going to start with a little video. How many of you know why this is called the Napi lecture series? Oh, you don't need the video. Yes, you do. You still need to see the video.
That's why it's called the Napi lecture series.
Excellent. Perfect. Thank you so much. So we're going to let you know why in this wonderful video that actually Katie put together because she's multi-talented. So I'm going to go off this right now and we're going to start the video. So thanks for your attention. Then we'll get going.
I knew Napi really, he was a decade older than I, but I knew him well as sort of the older kid. Now, Napi, of course, told lots of stories about his life, but the man that I knew, the boy that I knew, was just a friend in the neighborhood. Napi and I had talked about the center when we first formed our association, before we even were the Center for Coastal Studies. He was in the process of building his restaurant at the same time that Barbara Graham and I were in the process of coming together for the center. And I think the thing that galvanized the relationship was the rescue of Ibis, when Dave Matilla and a team of people from the center and I got together and freed a whale that would certainly have died. What Napi and Helen did, really an indication of their passion, is to set us up at the Center for Coastal Studies for probably many, many decades to come. Napi often spoke to me about the importance of stability. He used to talk about how it was important that his restaurant become financially stable early on. And he spoke about the center in the same way. They both had a profound passion for the work that the center was doing. And I think the gifts from their estate really speaks to their desire to see there be stability and a future for the institution, which they really loved. Napi might not have said, "I love it," but I guarantee, knowing in Napi speak, that's what he did.
Well, who here knows it's our 50th anniversary this year? Oh, I see. I'm going to be loud. This is bad. Well, 50 years of research, rescue, and education to understand, protect, and conserve our coasts and our ocean for the benefit of all of us. Yes, yes. It's an incredible team, and we can't do it alone. And so now on to the main event. I'd like to introduce Katie. All right, I know you can keep applauding for her. You're going to want to applaud early and often. So Dr. Katie Castagno is the director of the Land-Sea Interaction Program at the Center for Coastal Studies. Her research interests focus on the intersections among coastal resilience, salt marsh restoration, and sediment transport. Katie received a PhD in geological oceanography from the Massachusetts Institute of Technology / Woods Hole Oceanographic Institution Joint Program in Oceanography. Oh yeah. That is a no-joke program, by the way. Katie also holds an MA in Marine Affairs from the University of Rhode Island and a BA in Environmental Geoscience from Smith College. She's a triple threat. Yeah. Katie's previously worked as an environmental educator and elementary school science teacher across Cape Cod. You will see that skill set here tonight. It's a joy. She's multi-talented. She has also shared with us her talents as a singer and songwriter. And I don't know, do you have CDs tonight, Katie?
Yeah, I thought about it, but I forgot.
Oh,
come see me afterwards.
Come see her afterwards. Totally incredible. As well as her prowess as an interviewer and videographer, she's created this video as well as profiles of some of our CCS friends and family for our 50th anniversary. We're lucky to have her on staff. We're lucky to have her helping tell the story of some of the greatest ecosystems on this planet that we enjoy right here. So I give you Dr. Katie Castagno.
Thanks everyone for coming. I'm Katie Castagno. I'm thrilled to see you all here. I have been asked to talk to you about the Land-Sea Interaction Program through Geologic. So one of the most exciting things about the Center turning 50 is in the last 6 months, no, it's March, 3 months. It's been the longest 3 months of my life. I'm sure you all feel the same. I had the opportunity and really blessing to conduct oral history interviews with some folks that are really pivotal to the center. So some of them have been through interviews done by Dennis Minsky and Hussein McFarlane. You'll probably hear them in the background a couple times. But also, I was able to just conduct oral history interviews with folks who, I had a crew from the 80s and a crew from the 90s. And is anybody here that I actually haven't interviewed? Oh, I hope I don't. Well, what I'm here to say is that if you feel like you have a story to tell, you should also come talk to me, and I'll encourage you to do it. But let's start with geologic time. So I wanted to start right at the very no, okay, that's too much. My undergraduate degree would maybe get you back down the Haitian. But the way that I like to think about it, right? Geologic time is a huge concept. And we really want to talk about how Cape Cod formed. And when we put that into context, Cape Cod only formed during the last ice age. So maybe you've seen this before, but the good way to think about it is geologic time is a clock. And if 1 second is when Earth's crust forms, the ice ages are 59. So when we're thinking, I guess this is what Bob was saying, I don't know, it's an hour. They've already been refreshed into an hour. So when we're thinking about it, what we're talking about in terms of all of geologic time is really just a small little bit. But to save this presentation from being 6 hours long, we're going to just start at the ice age and move forward. And so first, maybe you'll recognize this video if anybody's ever gone to the National Seashore Sands of Time exhibit, you'll recognize this. And I was looking for an animation or a way to describe it. And I was like, I just really need that video from the visitor center. And turns out you can get it on the internet. You can get anything on the internet. So I just wanted to say Cape Cod again is relatively new. And so let's see if this goes. About 20,000 years ago, the Laurentide ice sheet reached its most southern position. And so here you're zooming in on Cape Cod, and you can see that it was moving back and forth, and we have these moments of deposition of glacial deposits pushing up into a moraine. We have meltwater streams. We have kettle ponds. All of these are being formed by the glaciers, and then glacier retreats. We get Glacial Lake Cape Cod, now Cape Cod Bay, and then as sea level continued to rise, we get something that looks a little bit closer to what we know and love today. All to say, glaciers are incredibly powerful, and Cape Cod is mostly glaciers. I'm a geologist, so I would be remiss to not include my favorite glacial landform, the glacial erratic. I just really love a really big rock. So, who's seen Dome Rock in East End? Great, largest glacial erratic on the Cape. But maybe you're familiar with a different one?
And I think we should bring an archaeologist here to find out the true history of the Staples Rock.
Funny you should say that.
I'm Katie Castagno. I am a PhD in geology. I'm a geologist.
She just showed up here. We didn't invite her here for this story.
This rock was deposited by glaciers about 15,000 to 20,000 years ago.
That is a true story. I was just at Staples Rock, going to see that. I heard from the Facebook groups that there were eyeballs, and I wanted to see the eyeballs. And then there was a newscaster there, and he said, "Do you want to share your feelings?" And I said, "Well, I am a geologist." Anyway, moving on from that moment, my 15 minutes of fame.
So what is it?
So Staples Rock is also a glacial erratic. Yeah, so if you're not familiar, maybe if you're, don't spend a whole lot of time in Orleans, in the Staples parking lot, it seemed kind of under the cover of nightfall, all of a sudden there was this huge rock in the parking lot. They were excavating to do sewer work, and they just found this big rock under the ground, put there by glaciers. And it actually, I think, broke some of their equipment and broke some of the parking lot. So they decided they would just leave it there. Plus, last summer, somebody did drive directly into the Staples. And so they thought that the rock would deter future damage. We know that Cape Cod formed through glaciers, but I also want to talk about Provincetown because I think one of the most important things about the Center for Coastal Studies is that it's located in this really incredible space called Provincetown. But from a geologic perspective, let's think about this. So first, did you know that you can watch a YouTube video of people driving from Eastham to Provincetown? So in case you weren't familiar, or if you were coming from points north today, you see all this shrubby pine, and then you get to Provincetown, and it just looks different. Oh, it's like I timed that transition. So you can see that the landscape is really vastly changing. Like as soon as you really get to the harbor, you're like, okay, things have changed. So that's because Provincetown and these points north from about Truro have been formed from longshore drift and from sand deposits. And then ultimately the Provincetown dunes were formed by wind transport, or if you're a geologist, aeolian transport.
Wait, say that again?
Oh, yes. Aeolian.
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 What's that?
Aeolian.
Yeah.
Did I do it?
Yes.
Kind of. Yeah. I love that was a word that I learned in grad school and I like held on to it forever.
What does it mean?
Wind blown. Wind.
Aeolian.
Wind. Yeah. I don't know what language it's from. I never took Latin.
It's great. It's great.
Thank you. Then I really wouldn't have helped even if I had taken Latin. So anyway, let's go back about 10,000 years. So here we have Provincetown, the current shoreline, and then in the dark line, that's about what the shoreline looked like. And remember, sea level was about 30 meters lower at this point because sea level had to rise from after the glaciers retreated. So about 6,000 years ago, it's getting to be a little bit closer to what we think of as Provincetown, about 5,000, 3,700, 2,000 years ago, and finally today. So it's been a long process. And this is all to say, again, we're really playing with this idea that the Cape is always changing. Cape Cod is always evolving. It's a young landform, and the ocean is a heck of a force. So those are from this paper, but maybe you recognize this author. This cited this other paper very liberally. Maybe you recognize this author. So Graham Geiss was one of the three founders of the Center for Coastal Studies. We have some relatives in the audience, I think. Okay, I thought I'd maybe get like a whoop whoop, but we don't. Yeah, thanks, great. Abby in the back. Thanks. Yeah, so we've got some folks. But I think Graham Geiss was the original founder of the Land Sea Interaction Program, and he truly a geologic great. And I think one of the joys of this presentation is that we were able to conduct an oral history with him. We went up to Cambridge and we sat down with him for an hour and a half just to chat about his story and the start of the Center for Coastal Studies, which was really incredible for me as I've been here for 5 years and I'm like, I'm a baby. I haven't been here for that long. And just to really understand the beginnings of such an incredible organization has been really impactful to me. And I hope it's impactful to you as well. Graham Geiss has been working on this for a long time. This is his 1964 master's thesis, Coastal Orientations of Cape Cod Bay. So I love an origin story. So this is a little clip from an oral history archive from Hui in 2008 that Mark Adams found for me, actually. That was really incredible. And this is a little bit of Graham's geologic origin story.
Probably the one thing that happened to be one afternoon that does play into my later life. There was a man who turned out to be a surveyor walking with some equipment over his shoulder, and somehow or other I got talking to him, and it was interesting what he was doing, and he took me down right where the breakwater is, and it turned out that he was erecting a signal over a benchmark, or triangulation point really, just back from the beach. So I was very interested in that, and told me about his work. And I never saw him again. Every now and then I would go down and look for that monument. But it turns out that I did work very much like that later on.
We love an origin story. So let's dig a little bit into the history of the Center for Coastal Studies. Founded in 1976 by Stormy and Barbara Mayo and Graham, and they came together to incorporate an organization that really blossomed into the one that we know and love today. And I figured I could just show you a little bit about what they have to say about it. I've got some quotes. We've got some clips here from Graham, Stormy, and our former executive director, Rich Delaney.
When we came together to give courses in coastal marine ecology. That's how it all started. Well, I was interested in coastal geology, and so I asked them if they wouldn't join me in giving some talks. Actually, Rich Delaney took that course, that first one.
Well, my first experience with the Center for Coastal Studies actually goes back to the year before it became an organization, when Stormy and Barbara Mayo and Graham Geis, all three of them offered a field walk, or 1 week worth of field walks for anyone who wanted to sign up.
We had advertised a non-credit course for people without any requirements at all. But we had some remarkable people, and one of whom in that first class was Rich Delaney, who was just sort of getting his feet almost literally wet with marine science.
Only 3 people signed up for the class. John Worthington, who was a famous person in Truro, myself, and a young, 10-year-old kid whose parents, I think, wanted to keep him busy for a week during vacation. So that was my first experience. So we walked around over the dunes and did 5 days worth of wonderful exploring. And I learned more about Cape Cod in that 1 week.
We gave our talks, each one of us. We didn't have anything very formal, but we'd done an awful lot of research, so we could go out on a beach, and if it was blowing hard and there were waves, Graham would give one of his classic conversations about how the waves were being bent by the breakwaters and how they were breaking on the shore. And I mean, I had a lot of oceanography in my background, but he is such an eloquent speaker that he was able to make it all come very much alive.
Mm-hmm.
We were still not the Center for Coastal Studies, but it got to be interesting enough so that after a couple of years of that, Graham and Barbara conceived the idea that we ought to name and get a nonprofit status. And they came up with this, what I thought was a very puffed up name, which was the Center for Coastal Studies. I said, it's 3 people. How can we have just 3 people walking around on a beach and you're going to call us that?
Center for Coastal Studies today. Yeah, so now the Center for Coastal Studies is an organization of about 50 people. We do really incredible top-notch science. This is a drone photo from our drone pilot, Dan Salazzo, at our December retreat. We said, we should take a group photo, but how are we going to do it? And Dan said, let's get the drone. There's a lot of them, but this was probably the one where most of us were looking. But of course, Dan is not. Yeah, I had to do some Photoshop. But regardless, it's just really been incredible. And when we talked with Graham, he really mentioned that a lot of it was, being in the right place at the right time. And we know Stormy talks a lot about serendipity. So I have just a little clip about how important it was to be in that right place at the right time, all within the incredible timeline of the environmental decade of the 1970s.
It was just at that time. We just happened to be there. We just happened to have the background we had. Stormy happened to have been born there. I'd been there for 20 years. You just can't, do much more than sit back and look. And and be all like as we always are by nature. Especially, I think, it's in my mind as a geologist, it's really this is just the geology part, but is the loose sand, the movable sediment. You can concentrate on that part of incredibly complex coastal systems. You can concentrate on one, almost say small part, one part of it. Now that and is changing right in front of you because it's geologically such a new system. System that's part of a much bigger system. Talking about subsystems, I mean, Cape Cod's part of the systems of these Pleistocene deposits. They're part of ice ages, and if you go further back, they're part of the growth of the continent, across the continental shelf, and the slope and the whole 9 yards. So, yeah. So I think it's we were there. It was something that should have, was waiting to happen. You could say.
But it wasn't just the classes. So it was actually a moment that both Stormy and Graham mentioned was that they got together, they met at a hearing to discuss the construction of a solid fill pier in Provincetown. We've got a little bit from this.
A local movement to make some changes in the structure of the piers in Provincetown, the so-called CJ pier, which was at that time a standard-looking pier, was being proposed to make that a solid fill pier, and it seemed to be right, kind of railroaded at dawn. I mean, there wasn't. I didn't see. I don't think Stormy saw. I'm not aware of any great opposition before ours. Now, probably there were lots of people like us, who were thinking the same way. It's just that we happened to be talking to each other.
This fella Graham Guys was sitting way over in the right at some hearing in Town Hall, in the main room of Town Hall, and he was over in the corner, and I didn't know who he was. I knew there was a group of people in town who were concerned about tearing up the bottom and a huge amount of potential change in the wave energy and the like. And then he stood up and started talking about it, and we didn't have anything, I think, even prepared, but we worried about this thing that was being planned, and that was the way we met. And so to some degree you could say that was really the seed that eventually flowered.
I can remember his father using an image, something like, this is our garden, the shore in front of Provincetown is our garden. We think it's our garden, and we need to protect it. I mean, so in that sense, they were looking at the total, ecological framework. I was interested in sand movement and waves and things like that, and it was pretty clear that there would be a major effect if they had made that a solid fill pier on the sediment movement along the shore.
So it all comes back to sediment transport. My favorite. It's something that Graham and I think about a lot. And, so here there was a 3-part special edition of the Cape Cod Chronicle and some other newspapers too, with Graham and Rachel about erosion, which was a really incredible way to build understanding to the general public. But one of the things too that I think is really key in terms of the history of both Cape Cod and the Land Sea Interaction Program is Graham's work in Chatham. And so here's an example from the barrier beaches of Chatham. And Chatham, we talk about Cape Cod as being a system in transition, but when we think about Chatham, when we think about those barrier islands, it is truly a system in transition. Yeah, so here you can see it's going from 1984 to 2016. And I mean, you can see that shifting sand, that's 20 years. It's more than 20 years. It's been a long day. So I'm into sediment transport, but not maths. So you can just see the systems changing, and all of that is from the sediment transport. So, and this is also great because it has really important implications for things like coastal protection and access for boats. So Graham made a prediction in the 70s. He successfully predicted that the Chatham Inlets change on a 140-year cycle. An inlet develops and the barrier migrates. And he noticed this by compiling a ton of old maps and charts and looking at cycles of land change. And so these are from one of the these are a little bit, I guess they're not quite from the original publication. They've been updated a little bit, but they're displayed chronologically in 20-year segments, but I'm going to kind of hop around a little bit. So in 1846, an inlet in Chatham formed near Minister's Point. So you can see, okay. All right. So people who aren't on Zoom, you can see where the inlet formed. Great. Okay. The barrier then continued to migrate southward. So again, we're going forward in time every 20 years. By the 1940s, Graham realized that the shoreline had begun to look suspiciously like that of the 1800s, which led him to hypothesize that an inlet would develop about 140 years after that last inlet developed. The idea is these guys, I'll do it again, these guys look similar in time. So 140 years after that last break is around 1986. So again, those future predictions that somewhere, these are by 10-year intervals, there would be a break. Maybe you were around in 1987, January 2nd, perhaps only 2 days off if you're really splitting hairs. Northeaster cut through North Beach and basically right where Graham said it was going to, which is really incredible because I think it's important to point out, and Mark Burley always mentions this, that scientists don't like to make big predictions like that. But Graham knew, and he did it, and you know what? He was right. So for an example, show you what that looks like. 1984, this is, I'll draw your attention to the number 12 here. 1989, wild cut. And I just wanted to kind of wrap up the Chatham section. And now we're still doing research in Chatham. We're still doing a ton of work. The system is changing all the time. And we're really trying to figure out how it's changing, what had happened in the past, and how it might change into the future. And Sandy McFarland, when she was interviewing Graham, asked him, like, well, how did you know? Like, of course you knew. And I just really liked how he responded with this.
We're curious people. But that's really what we try to unravel all the time. You don't start that way. You start by seeing something's going on, what is going on, and where is it, and what are the elements going on in here. It's later, after you get the feeling for it, you begin to understand how that particular system works. But let me just say that it's not that we knew the answers and then came and told everybody. It's just that we were in there trying to understand the same. This is what we're trying to understand. Mm-hmm. And that's what we're still trying to understand.
And that's true. I think that scientific curiosity is really a thread through the center. And because we're able to be flexible, be proactive, we're able to really pursue those important scientific questions. Again, we talk about this a lot, and this is just one more example from this. So, one of our research vessels is called the Merindon. And it's named after this guy, Henry Merindon, who was the first person to map the marine and terrestrial systems kind of as one. And he made took 229 profiles in 1889, in the 1880s, 1890s even, from the top of the bluff out to the water. So looks, oh God, I might freak out. Okay, did it. Perfect. Looks something like this. And in the kind of early aughts, Graham and Mark Adams went out and they resurveyed these, which meant that we have this incredible data set of 100 years to be able to compare and look at how shoreline transport and sediment transport along the shoreline is happening. And here, this is just a quick clip from our oral history with Mark Adams, which I thought was a great way to describe how it happened.
That protocol of shoreline monitoring, which was a good start for the National Park Service, after talking it over with Graham, we realized there was a much more interesting approach. Graham, at one point, he told me about Henry Merindon, and we were at the North Shore Lab, and he said, There's a point, station 136 out on the cliffs in North Truro, that I'd like to find. We have the coordinates, how do we convert them? We converted them from the previous coastal datums from the 1890s, and we went out and navigated the brush. I spent so much time walking through brush with Graham or driving to the end of the beach. It was so satisfying, and it was really great for me because he was teaching me all the time. But we found station 136, and we measured, we got locations for the breaks in elevation and stuff. And I was like, yeah, okay, that was fun. And then he goes, do you want to do 228 more of those?
So eventually we've gone from this, and this is an illustration from the 70s article, to this. So this is actually a plug for Map That Cape Cod. If you haven't been to Map That Cape Cod, and I see some people are pulling out their phones, and I support that wholly. Map That Cape Cod is a data portal that the Marine Geology Department has been working hard on. Our colleagues, SJ and Steve, have been working to get all of this data and make it available to average people and specifically to decision makers in the towns. And so really incredible data source. Check it out. And it's cool because you can see where the sediment is, the sediment transport pathways, this whole area. So it's all to say that the coast is changing. We see these sea level is rising. I always really like to include these pictures of the stairs at Mark Beach in, I believe, 2017, 2018, and 2024. They did survive the blizzard of 26. But today, I'm really excited to take the Land Sea Interaction Program, just continue Graham's legacy into the future. I love an origin story. I had my mother go digging to find this photo. And I think my origin story was probably at the Wealthy Bay Wildlife Sanctuary, where I was a day camp kid. And here I am. You can't really see it, but I am in fact holding a fiddler crab in the salt marsh. I couldn't find any photos of me head to toe covered in mud, but believe me, they're there. So most of my research focuses on salt marshes, which are really key ecosystems at the interface of land and sea, the interaction. I've started with the program in 2021, and I've been able to take dozens of young people into the field while supporting our research, whether they're research assistants or students or summer volunteers, or I've even been able to take groups of high school students from our after school program into the field. And it's just really incredible to get folks out there and see how important these ecosystems are, especially folks that are, especially the kids that are from the Cape. Like, this is their backyard, and it's so important for me to understand and for them to understand what a beautiful resource that we have. Salt marshes are really, one of the reasons why I'm so passionate about salt marshes is that they are really important for coastal protection. And so the example that I always use, which works well for this crowd, but I gotta tell you, doesn't work as well with college kids, is Hurricane Katrina in 2005. The college kids weren't born. But Hurricane Katrina and Rita in 2005 made landfall at similar intensities. They were both Category 3 storms. But Hurricane Katrina was really devastating, much more so than Hurricane Rita, because Hurricane Rita traveled over 30 to 50 kilometers of wetland before it reached a populated center. So when we think about impact, we think about salt marshes, and we think about their ability to attenuate coastal flooding and storm waves. And just, aside from all the other ecosystem benefits, like they're good for the water and they're good for the shellfish, and we just love to take a kayak into the marsh. This is important because we know that storms are increasing. So this is looking at, this is a result of a bunch of climate models, but basically what it's saying is that by the end of the century, more than half of the storms that form in the Atlantic will become Category 3 storms or higher, or about half, not more than half, approximately half. Not to freak you out too much. It's not to say that storms are going to be, there are going to be more storms, but the storms that do form are going to be more intense. And we know that we're reaching a tipping point. We know that landscapes are changing. So here, this is an example. I'm sure some of you have heard me talk about Duck Harbor and Wellfleet, where in 2021, on a fair weather day, there was an overwash, just extra high tides, breached the dune. And eventually this happened almost monthly now and has caused astounding ecosystem change. It killed about 120 acres of trees from the salt water. But most interestingly, this area is all part of the Herring River floodplain, which is, as I'm sure you are all familiar with the Herring River Restoration Project. But this area used to be a marsh before it was a forest. And now that we see that it's getting regularly inundated, we're getting salt marsh vegetation to come back. So it's kind of like watching Mother Nature's salt marsh restoration project. But then there's the big one down the road too, as well. So one of the things that I do for this is I take sediment cores. I want to look way back into the future, or way back into the past. And so this is sped up 8 times. And it actually, I just want you to know that this was taken by a Park Service employee who had come to see how we were doing. This is out at Duck Harbor. And I was like, oh my God, it's going to go so wrong. And it's never been smoother. So if you think this looks hard, this is like the easiest 4 we've ever taken. It does take 4 people. Again, I've never been stronger. So for example, and we can talk about a lot of these things, but for the sake of time, we took a bunch of sediment cores in Duck Harbor to really figure out what happened before. We know that historically it used to be a harbor. We know that it used to be a marsh, but we really want to know, how has the system changed? And you can see over here, maybe afterwards you can come look at the cores that we took to scale to get you a sense of how deep they actually are. So it's a lot of mud that we're bringing home, not for lack of trying. So just to give you a really quick idea of what these sediment cores can do, is here are 2 sediment cores from Duck Harbor. And if you can see this line here, it might be a little bit hard to see on the screen, but there's this really strong differentiation between sand and then a mud. And it's a pretty sharp contact. And that happened in the early to mid 1600s. And we were trying to think, what sort of environmental thing could cause this massive environmental change from mud to sand? And the contact is sharp, so you know what happened quickly. Does anybody know what happened in the early to mid 1600s?
Hurricane.
Yeah. All right, perfect. So the Great Colonial Hurricane of 1635. It hammered New England as a strong Category 3 storm, wind speeds close to 130 miles per hour. And this is just a slosh model. We're looking at estimated storm tides. And you can see as the hurricane comes through, it's passing a little bit to the north. But there's this incredible focusing effect right at the end there. And I think it should stop at the end, but we'll see. Perfect. Okay, so you can see that there's this incredible focusing effect. And do you know where that is? Yeah, exactly. So it's not surprising that we see this dramatic change, this incredible shift in the ecosystem in these cores. And it was so incredible to say, okay, let's take these cores and figure it out, and then go backwards and say, wow, this actually makes total sense from the models. I don't know.
So how deep is that now? What depth was
Yeah,
that?
so
The question was planted.
it was planted. I'm going to speak really loud for people on Zoom. All right, so the mud here, this is like a foot down, and this is about probably 2 feet down. So for these guys, but our cores, we were able to go back, for our cores, we were able to go back about 6 feet, I think was the deepest we were able to get. But when you go down even only like a foot or 2, that's where you see that contact. Super interesting. Just under your feet. You wouldn't realize it. You wouldn't think it. That being said, I just really want to say that this work is done on the shoulders of giants. I mean, the caliber of research and education about coastal processes that Graham, the Land Sea Interaction Program, and everybody in the Marine Geology program has done is just really something that I aspire to. And of course, I mean, here's Graham today at 90, he's still at 94 researching coastal processes. So unstoppable. What do they say? It's like geologists. Oh, okay. This is maybe something that I'm going to do it anyway. Geologists never die. They just slowly like fossilize. But anyway, it's fine. So here's, I'm going to be a million years old and just like a beautiful piece of like petrified wood. But with that, I really wanted to end with a quote from Graham about just like the special community of the center, especially in the light of the 50th anniversary. I just think it's so important to really be here and be part of this incredible community. And I'm really grateful for you all to be here too and be here for this incredible community.
So that was the only reason that it became what it became, is that people cared about it. It wouldn't have been known around the world if someone around the world didn't want to know about it. So it was really human curiosity and then focus in that area that fed the center. But it's a kind of a feed and being fed. There's got to be a word for that, but and nature works that way when it's to nature's advantage to work that way, and that's how the center was. Yeah, there was this opening, there was this need for it, an opportunity for a few people, but there was also a need and an interest in the community, and then the community is bigger community until you cover the whole world.
So thank you for being part of this community.